Jai Hind. So today's topic is MOSFET, and this topic has been taken from the subject Fundamentals of Electronics Engineering, that is BEC 201. So this is the lecture 4. So MOSFET stands for metal oxide semiconductor field effect transistor, and it is different from the junction field effect transistor, that is a JFET, because it has a something, there is a in this, that is extra in this MOSFET, that is semiconductor oxide. Semiconductor oxide is not present in the JFET. This semiconductor oxide, it provides high insulation to the MOSFET. That's why its input impedance is more in comparison to the JFET. And also it is also called, a MOSFET is also called as a insulated gate, IGFET. IGFET means insulated gate field effect transistor, because here gate is insulated from the channel, but in case of JFET, gate is attached with the channel. And there are two type of MOSFETs, depletion type MOSFET and enhancement type MOSFET. In depletion type MOSFET, we will see with the application of the VDS voltage or VGS voltage, and the current, ID current will increase, drain current will decrease, in this case depletion type MOSFET. And in enhancement type MOSFET, current will increase. Depletion type MOSFET, it will work in two mode, depletion mode and enhancement mode. And enhancement type MOSFET will be working only in single mode, that is the enhancement mode. So this is the depletion type MOSFET. So here we can see this is the N channel. So basically we can construct it like in this we have to made a P type substrate. We are making a N channel D-MOSFET. D-MOSFET means depletion type MOSFET. So for constructing N channel depletion type MOSFET, we have to take a P type substrate here. This is a P type substrate, and in this P type substrate we will make a doping of N type material. Like this is the P substrate and doping of N material is there, and this is the N channel. This channel is there, and this is a layer of the SiO2. And here we can make a metal contacts like in this way. So this is the drain, this is source, and this is gate. So this SiO2 layer is present in between the gate and the channel. This is a P type substrate. These two blocks and these are acting as a drain and source, and between these two blocks there is a channel, that is called the N channel. And over this channel there is a SiO2 layer. This layer is SiO2 layer. It provides high insulation to the MOSFET, and it protects the entry of the charge carriers into the gate from this channel. So for the conduction of the MOSFET, drain and source are given supply. So this is connected in this way. Source is since this is an N channel, so source will be connected with the negative supply, because source from this side charge carriers will be emitted and they will be moving like in this way. So if it is, this is an N channel, so electrons will be in majority. So electrons will flow from this part to this part. So that's why source will be connected with the negative supply, because so that due to the repulsion of this negative force, electrons will be forced to move towards drain side. Drain will be connected with the positive supply. Now this gate and source is there. So this depletion type MOSFET works in two mode, depletion mode and enhancement mode. In depletion mode, with the application of the VGS voltage, number of charge carriers in the channel will reduce. They will move towards the bottom side. So current will decrease. And in case of the enhancement mode, with the application of the VGS voltage, number of charge carriers will increase in the channel, and that's why current will increase. So if we like it, we are making it in depletion mode. In depletion mode, what we will do, we will connect this G with the negative supply and source with the positive supply. If we connect G with the negative, gate with the negative supply, it means there will be a negative charge here and this negative charge here. So this negative charge will repel the electrons that are available in this N channel, and these electrons will migrate towards the bottom side. So number of electrons will reduce in the N channel, and due to the reduction in the electrons, due to the reduction of electrons in the n channel, the current in the channel will reduce. So in depletion mode, VGS is negative, and ID current will reduce. And enhancement mode, in enhancement mode, VGS would be positive and ID current will increase. Now if we connect the gate with the positive supply, this is gate and this is source, gate with the positive supply and source with the negative supply. So this positive supply of the gate will attract the electrons from the p-type substrate. In p-type substrate, electrons are in minority, so these minority electrons will be attracted towards the channel and current will increase. So this is the case for the enhancement MOSFET. So this diagram depicts the here this is a source, substrate and source are short circuited also in some of the cases. So we can see here drain and source is there. Here VGS 0 condition has been shown, and drain and source is connected. Source is connected with the negative supply because channel is N type and electrons will move towards this side. So the ID current will be flowing, and here VGS is 0. So VGS is 0, so there will be no mode, neither it will be depletion or it will be enhancement. This is simply like in this way, like we are increasing the VDS and this is our ID. So like we are getting this curve. This is the VGS 0 and this current is your IDSS current. The same curve that we were getting in the GFET, same curve is there, because with the increase in the VDS voltage, here channel depletion regions will trying to touch each other and channel width will get reduced. So the constant amount of charge carriers will be flowing, so constant amount of current will be flowing, and this is the case when VGS is 0, and this is called the IDSS. And now if we apply the negative potential here, like this is VGS minus 1 and this is VGS plus 1. So this is the depletion mode, because with the application of negative voltage of VGS, current is reducing, and this is the enhancement mode. And this curve is basically is the drain characteristics curve. Drain characteristic. So here we can see also with the application of negative potential at the gate, this electrons will repel from the channel and it will migrate towards the p-type substrate. This is a p-type substrate and this is our channel. So with the application of negative potential at the gate, electrons will be migrated from channel towards the p-type substrate. That's why there will be deficiency of the electrons in the channel, and that's why it will lead to the decrease in the ID current and it will work in the depletion mode. So here these are the graphs for the this is the drain characteristics curve and this is the transfer characteristics curve. Drain characteristics curve is always plotted in between ID and VDS, keeping VGS constant, and it is always plotted in between transfer characteristics curve in between ID and VGS. So this is for the N channel, and here we can see this VGS 0, IDSS current is there, and for VGS plus mode, this is the enhancement mode. This mode is enhancement mode and this mode is depletion mode. So here also we can see this part is of enhancement mode and this part is for the depletion mode. In depletion mode, VGS is negative, so that's why its orientation is like in this way, and enhancement mode VGS is positive, so its orientation in this way. So if we want to make for the P channel, okay, so this is for the N channel type MOSFET that we have discussed in previous slides also. Okay, so this graph is for the P channel. like if you want to make for P channel, this is our N substrate and this is P block and this is P channel. So this is for P channel. Now there will be a SiO2 layer here and these are the connections through this. So this is drain, this is source and this is gate. Okay, so now we can see we have to connect the drain and source. So now the channel is of P type. So here the charge carriers will be of holes. So we have to connect the source with the positive supply. So that holes may be repelled from this part and they can move towards this part and current will be flowing. Now we have to connect the VGS. So we can connect the VGS in two ways, so that it may be operating in the depletion mode or it may be operating in the enhancement mode. Okay, so if we connecting it in the we have connected gate as negative, VGS as negative. So what will happen? Negative charge will be here and this negative charge will attract the more number of holes from this part to this part. So the holes that are present in minority charge carriers in N-type substrate, they will move towards the channel and they will increase the number of the charge carriers in the channel. That's why if VGS is negative, ID current will increase in the channel and it will be working in enhancement mode. And if VGS is positive, then if this VGS is make positive like this way, source is now negative and gate is now positive. So this positive potential will be here. Now this positive potential, it will repel the holes that is available in the channel and these holes will move towards the substrate. So it will create the deficiency of holes in the channel and that's why ID current will decrease and this will be called as the depletion mode. And this graph we can see here, this part is the depletion mode when VGS is positive and this part is for the enhancement mode when VGS is negative. So this is the enhancement mode and this is for the depletion mode. Okay. Now MOSFET, depletion MOSFET, this is the case for the depletion MOSFET and that is operating in the enhancement mode also and depletion mode also. And this is, it follows the Shockley equation, that is Shockley equation is ID is equal to IDSS 1 minus VGS upon VP whole square. So it follows this equation. Now if here we will put VGS is equal to VP, so ID would be equal to 0. At VGS is equal to VP, ID would be equal to VP. ID would be equal to 0. This is the case. Here we can see at this line we can see VGS is equal to VP, that is plus 6 volt, and we can see the current amount of current is 0. So this VGS, this VP is called, this VGS is called as the VGS off. Now in this case it is called as VGS off. VGS off means at that potential, that VGS voltage which is equal to VP, and at which the MOSFET will be in off condition because no current will be flowing, no ID current will be flowing. So MOSFET will be in off condition in that case. And here if VGS is equal to 0, in this equation we put VGS is equal to 0, in that case ID would be equal to IDSS. So here we can see this VGS is 0, so this ID would be equal to IDSS. Here we can see this VGS is 0, so it would be equal to IDSS. IDSS means drain to source current with gate and source is short circuited. So this is the symbol for the depletion type MOSFET. Here we can see this gate is insulated from the channel. there is no connection. This part is the channel and this is the gate. So gate and channel both are insulated, both are isolated here. And here also this gate and channel both are the isolated. Here also it is isolated. That's why it is also called as the IGFET, insulated gate field effect transistor. Insulated gate field effect transistor. After that, enhancement MOSFET is there. So enhancement MOSFET, so here we can see in enhancement MOSFET only works in the enhancement mode. It does not work in the depletion mode. And there is a major difference between the depletion mode and the enhancement mode. The depletion mode already has a channel. Means manufacturer make a channel in the depletion type MOSFET and we use this. But in case of the enhancement type MOSFET, there will be no physical channel present in the substrate. But there is an induction of the channel in the substrate. So like we are taking the case for N channel E-MOSFET. So here the for N channel P type substrate is there and these are the N blocks here. This is the N channel. There is no channel here, sorry, there is no channel here, and there is SiO2 layer is there, and this is the, okay, here there will be no channel. Okay, and this SiO2 layer is there, and this is drain, this is source, and this is gate. So there is no physical channel in between these two blocks that was present in previous case. Now an SiO2 layer is there, gate is isolated through this substrate with the help of this SiO2 layer. Now drain and source connected in this way, like source will be connected with a negative supply because it is a N-type channel, and N-type E-MOSFET, and here now we have to connect the VGS, gate and source. Now gate and source will be connected in such a way so that the gate will, this potential will help to make the channel. So gate will be connected with the negative supply, gate will be connected with the positive supply. Okay, this will be positive and this will be negative. So this positive supply, it will attract the electrons that are present in the p-type substrate as a minority charge carriers, and these electrons, due to this positive supply, it will move towards the top and it will be collected here. So due to the majority of the electrons at this side, there will be a formation of channel. So here this VGS potential, it will help in inducing the channels in the MOSFET. So due to the positive VGS voltage, it will attract the electrons from the substrate to the channel. So electrons will increase, conductivity will increase. Now conductivity will increase. So and this VGS it has a threshold voltage VT. Means we have to increase the VGS up to a threshold level so that a proper channel may be constructed in between these two blocks. After the construction of the proper channel, then only this MOSFET will work. So this is the graph, this is the diagrams, and we can see gate, drain and source has been connected here, and VGS is given supply, VGS is given positive supply so that the electrons will be coming towards this side for the formation of the channel, and after that ID current will be. So this is the drain characteristics curve and this is the transfer characteristic curve. So here we can see when VGS is equal to VT, that is 2 volt. After that 2 volt, then only there will be a conduction of current. Before this VGS is not equal to VT or less than 2 volt, then there will be no conduction of current. So by increasing the VGS amount of current is continuously increasing, and here this is in transfer characteristics curve, we can see below this 2 volt the amount of current is 0 here. So VGS is increasing and ID is increasing. So this is the case when the N channel E type MOSFET is used. If we are using the P type channel, and this is the equation for ID is equal to K VGS minus VT whole square. This equation is applicable for the enhancement type MOSFET. So this is the case for the P channel in enhancement type MOSFET. So in this case for P channel, we will take N type substrate. So for P channel, we will have a substrate, N type substrate, and 2 blocks are there, P and P, and SiO2 layer is there. After that, this is the, now we have to connect the drain and source. So this source will be in like in this way, so that holes will be repelled from the source and it will be attracted towards the drain side. So this will be there, and now this gate will be connected with the source, and now it will be connected in such a way so that a channel will be formed here. So for the formation of the channel, there must be holes here. So this gate will be connected with negative supply and source will be connected with positive supply. Now holes will be the holes that are present in as a minority charge carriers in N type, they will be attracted towards this side and they will be collected here, and then there will be a formation of P channel. This is the induced channel in this case. So it will be required a VGS must be equal to threshold voltage. Threshold voltage means minimum value of VGS is required so that a proper channel may be constructed in between these 2 blocks. So here we can see this VGS is equal to negative potential. Here we have applied the negative VGS. So here we can see this is the negative side. In previous case, our curve was like in this way because VGS was positive, but here VGS is negative, so it is this side, and here this VGS is equal to the VT. So now here we can see if this VGS is less than the VT, then this diode will not be in conducting condition. Okay, so we in this topic, in this lecture, we have studied about the depletion type MOSFET and enhancement type MOSFET. Enhancement type MOSFET the channel was not there, and the induced channel was made with the help of the VGS voltage, and in depletion type MOSFET a channel is there in between the both blocks, and enhancement type MOSFET works in both modes, and depletion type MOSFET works type MOSFET works in only one mode, and depletion type MOSFET works in both modes. Thank you.